next section, we'll discuss what we call logical in-path configurations. So remember, a logical in-path configuration refers to WCCP or PBR, where we're not physically in-path, but we're logically in-path. Packets are being redirected to the steelhead using a protocol like WCCP or PBR. So logically we're in-path, but physically we are not. Let's start with WCCP. WCCP stands for Web Caching Control Protocol. It's a protocol that was developed by Cisco to allow Cisco routers and some switches to redirect traffic to one or more caching devices or target devices. In this case, we're talking about steelheads. WCCP is implemented by putting redirect statements on each router interface that will see traffic. And you can also add ACLs to those routers in order to restrict specific flows. Obviously, we're only going to want to redirect TCP traffic, as it doesn't make sense to try to optimize UDP or ICMP or various other flows. WCCP can provide high availability. We can have multiple routers redirecting traffic to a single steelhead or to multiple steelheads. And you can control how the traffic load is split among the steelheads. You can weight the steelheads differently, and you can set up some steelheads so that they only are utilized in the case of a failure by another device, or you can set up true load balancing. One of the most important things to remember here is that we're using the WAN 00 port on the steelhead when we are talking about WCCP. Next, let's talk about PBR, policy-based routing. So policy-based routing overrides the existing routing and allows routers to send traffic to the steelhead. Traffic that matches an access list is sent to the steelhead and is optimized and then returned. Policy-based routing provides a verify availability option so that in the event that a steelhead fails, traffic will not be redirected or black holed. If we're layer 2 connected to the router, then we can use CDP to make sure that traffic is not being redirected in the event of a failure. However, if we're a layer 3 hop away, then we can use object tracking, basically by sending pings between the router and the steelhead to maintain a knowledge as to whether the device is still up. Again, as with WCCP, we want to connect the steelhead using the WAN 00 port. When doing a logical in-path configuration like WCCP or PBR, we can use the configuration jumpstart as we can in a physically in-path configuration. Configuration will be exactly the same, except there are things that we'll need to do afterward. For example, we need to enable WCCP or PBR in the Configure Optimization General Service settings. We'll want to check the Enable L4 PBR or WCCP support on interface WAN 00 checkbox, as shown in this slide. For a WCCP configuration, we'll need to go in and actually configure WCCP, as you can imagine. We go into the Configure pull-down menu, choose Networking and WCCP. We enable WCCP v2 by checking the checkbox. Keep in mind we support WCCP v2, but not version 1. In fact, I don't think anybody would want to use version 1. Next, we provide the details of the router that we are going to be working with and define service groups and so on as described in the slide. Let's look at the configuration on the router for WCCP when working with a steelhead appliance. On the router, first we go into enable mode. Once we're in enable mode, we go into conf T, and we want to turn on WCCP service 61 with the following command, IPWCCP 61. Then we'll go into each interface and enable WCCP redirection. So first we go into FE00 and tell it IPWCCP 61 redirect in, meaning we want to redirect all the packets coming into that interface. Then we want to execute the same command on FE01. So on both sides of the layer 3 device. Next, we want to exit and save. In this example, we are going to be redirecting all traffic to the steelhead and appliance. As I mentioned earlier, we probably want to limit that traffic to TCP traffic. And in this example, we're going to redirect all port 80 traffic to our device. We do that using the configuration as you can see in the right-hand side using the ACL. WCCP best practices. Always make sure you compare the iOS version running on the routers with the very long list of iOS bugs associated with WCCP. This is the most common reason why deployments can go wrong with WCCP is an incorrect iOS version or an unsupported iOS version that is not supporting WCCP. Check the Cisco WCCP iOS version before attempting this type of deployment. It's always a good idea to check your design with the folks over at Riverbed. Get with your local SE and he or she can help you with that. Always try to be layer 2 connected to the steelhead. Be better not to have to traverse hops in order to get to the steelhead from the redirecting device. Also, we always want to use redirect in commands on the router as opposed to redirect out. A redirect out command on the redirecting device is going to make the device process the packet twice. And it's always a good idea to have the steelhead on its own subnet on the router or switch instead of putting it on the LAN side of the router or switch. So if you can get a port on the device that is doing the redirecting and you can make it its own subnet, that's the best way to go. Let's look at the router configuration for PBR. First, we're going to get into the router and obviously enable and config T. Then we want to set up a route map, which is going to define the next hop IP address as being the IP address of the steelhead. Remember, that's the in-path IP address, and we're cabled using the WAN 00 port. And we can set up next hop verify availability so that we don't black hole traffic and the redirecting device will stop sending packets to the steelhead in the event that somebody pulls the power on the steelhead or it fails in some other manner. Then we can set up an access list to permit TCP traffic coming from the 100.1.1.0 class C subnet over port 80 would be redirected, and the return traffic would also be redirected using these access lists. Then we go into the interface on FE00 and tell it to use the route map that was defined, and then we do the same thing on FE01. As I mentioned, all of the web traffic, the port 80 traffic from the class C 100.1.1.0 subnet and the return traffic will be redirected to the steelhead. Some tips when using PBR. Not all Cisco routers and layer 3 switches support verify availability. In fact, the 3750, 4500, 6K, and 6500 using SOUP2 do not support verify availability. However, the 3750 Metro, 3750E, the 6500 using SOUP32 and SOUP720 do support verify availability. When you're using verify availability on the router or layer 3 switch, make sure that you enable CDP on the steelhead. The command there is in-path CDP enable. Remember that verify availability using CDP only works if you're layer 2 adjacent. And if you're not layer 2 adjacent, use the verify availability command with the track option and the IPSLA command. This notifies the switch/router to send pings to the steelhead to verify its availability.